I told you to look at the extra. See, this is part of the extra that it's available in what's called extra. The extra I did myself for you. And in this extra, this chapter 11 in extra, I told you what is the strong force, which is ionic bond, metallic bond, and network covalent. We'll talk about them today. But last time we talked about hydrogen bond, van der Waals bonds, and dipole-dipole bond. And this is example. I told you to memorize this equation. Remember this equation?
Yes.
And I told you that this equation, for sure, you're going to see it in both next week quiz, and in the final. So very important Clausius-Capellán equation you must memorize, and the next week you will have a question from this equation in the quiz. Clear?
Clear.
Also, I told you how to find the coordination number, and we'll explain it more today. But this is very important also, very, very important. We said that we have 3 types of cubes. What are the cubes?
Simple cube.
What's the other one?
Face-centered.
Face-centered cubic. And the third one?
Body center.
You have to memorize the names. Then you have to know how many atoms are in the cube. In the simple cubic, how many atoms you have?
1.
1 only. What's the mass of this atom?
A/2.
No, the mass. You just go to the periodic table, get the mass from the periodic table, whatever it is. Let's say 125. From where I get this 125? 125.2. This is a number from me. From where do I get it?
From the periodic table.
Periodic table.
This is the element. No, usually it's below. Anyway, the mass, what's the mass will be? Because it's 1 atom. What will be the mass in what unit?
AMU.
Don't forget this. And also you have to know, if it's simple cubic, what's the relation between A and R? What's R?
Radius.
Radius.
What's A?
Radius.
What's A?
Edge of a cube.
Edge of a cube, exactly. If the cube like this is the edge A. All right? Okay, so you should know how to find this relation. If it's face-centered cubic, how many atoms are there in the cube?
4.
4.
What's the relation between R and A? R equal to what?
A√2
Over 4. You must memorize this. Memorize it. Okay. If it's body-centered cubic, how many atoms are there in the cube?
2.
2. What's the relation between R and A?
A√3 over 4.
And to memorize, the difference is only this is square root of 2 and this is square root of 3. Okay, just to help you memorize, right?
Doctor,
Yes.
A is fixed or it is changed?
No, of course not. What do you mean by fixed? Let's solve this problem. I'll tell you what's A in this case. Okay, gold crystallized and cubic closed back structure, face-centered cubic. Right away, how many atoms are there in the cube?
4.
4.
Center, how many?
4.
4 atoms. What's the mass of the atoms?
Uh, 196.97.
196 point what?
97.
Yes.
900.
And you must multiply by what?
By 2. By 4.
4.
By 4. It's base center, so it's by 4. And you'll get it in what unit?
AMU.
That's one thing. Okay. And the atomic radius of gold is 144 angstrom. 144 angstrom. What's this? What's given to you here?
R.
R. All right. Okay. Okay. What's the R is equal to 1.44 angstrom. If it's 1.44 angstrom, what's this equal to?
Multiply by 10 to the power of minus 10.
Minus 10 to make it what?
Meter.
Meter, exactly. 1.44 times 10 to the minus 10 meter. But I want the unit to be in centimeter. So how can I make it centimeter?
Minus 8. Minus 8.
1.44 times 10 to the power minus 8 meter, centimeter, exactly. All right. Can you find the density?
We have to find V.
What's the first thing you're going to do?
D equals M over V.
Find A.
First, find the mass. The mass is already there. But what do you want to change it to what?
Inverted
Gram.
How?
Divide by Avogadro.
Good. And how can I find the volume? I already have the edge. What's the volume?
Mass, this
Volume. What's the volume?
mass over this.
We
1.44 times 10 minus 8 cubed.
Exactly. A cubed, which is 1.44 times 10 to the power minus to the
Start,
power
doctor.
minus 8.
Doctor, we have to find A, right?
That, oh,
That's
yeah. Sorry. See, I'm making a mistake. Yes, of course. Oh, there is. Before the volume, we should find A. What we have is the R here. How can I find A?
R is A root 2 over 4.
A or R is equal to what? A root 2
Over 4.
4. So what's A?
for R over root of 2.
So let's find A. Calculate A quickly. I need an answer.
4.07 multiplied by 10 to the power of minus 8.
Who got the same answer?
I get
I get the same answer.
Good. Then calculate volume.
Uh, 6.74 times 10 to the power minus 23.
6.7 what?
4 times 10 to the power minus 23.
I got it as 6. I don't know.
Yes, it is 6. Yeah.
Yes, I get it 6.
Yes, I got it 6 actually. 6.76 times 10 to the power minus 3. Okay, find the density quickly. Yes.
Uh, 1.94 multiplied by 19.4.
Okay, 19.4. Yes. 19.
19.4.
I got it as 19.36
6.
actually. Yes. 19.36 gram per centimeter cube. Do you know how to find the density now?
Yes.
Is it easy?
Yes.
Yes, it
So
is.
I already gave you 2 questions from the quiz for last week. This question and question related to this equation. These are 2 questions already given to you. Okay, be ready for it. Okay, this is available in the extra. It's available also in the regular course chapter, but I deliberately put it in extra so that you can look at things. All right, let's close this. Okay, let's go back to the chapter then. Okay. As I said, what's this equation?
Calcius-Calpron equation.
Calpron equation. You must, the name is not very important, but keep it in your mind, and that's what we're going to ask you about next week. Okay, next. When we pack these atoms, we put them in one of 2 ways, either hexagonal close backing. Okay, memorize the name, hexagonal close backing, and they usually refer to it as HCP, in which you have, in hexagonal close backing, you have AB, and then AB, and then AB. So you have the first layer A, and then repeat it in B, and then you repeat A one more time. But you also can pack the structure in what's called cubic close back, and this is called CCP, cubic close back, in which you have A, B, C, and then you restart. So in hexagonal close backing, you have A after. This is how you put the atoms above each other, exactly like putting oranges. يعني الآن لما أعطيك كرتون وأقول لك حط فيه برتقال, how do you do it? You put the first layer, and then where do you put the second layer?
Above the first layer.
Exactly above it. If the first layer like this, where do you put the second layer? You put
Between.
it in between spaces here.
Yes.
Right?
Exactly.
Clear? And then if you put the layers A, B, A, B, A, B, yes. If you put it A, B, A, B, A, B, what's this called?
Hexagonal close back.
But if you put it A, B, and then you find a third place, which is called C, and then A, B, C, this means you repeat A, B, C every time. It's 3 layers, and you can see here, this is in the space, and this one in the space, but it's not exactly above this one. It's actually in between the others, and this is called ABC, ABC, ABC. What's the name of the close backing? This is called cubic close backing or structure. Cubic close backing. Clear? You have to memorize even the letters HCP and CCP. What's HCP? Yes.
Hexagonal.
Hexagonal close packing. How about CCP?
Cubic close backing.
Close back.
Good. All right. We talked about this. We solved this problem last time, but very quickly, I'm not going to solve it. You should solve it right now. Gold crystallized in cubic close backing, which is face-centered cubic, and has a density of 19.3. Calculate the radius of gold. Okay. As I said, if it's face-centered cubic, this means how many atoms are there in the atom? And the
4.
4 atoms. And so find the mass in your calculator. Go ahead. And then you have the density. If you have the density, what can you calculate?
The volume.
Okay. I want an answer only. What's the
Volume.
mass? What's the mass in gram? Give me numbers.
1.308 times 10 to the power of minus 21
Gram?
gram.
Who got the same answer?
Me too.
I want the third one also.
Yes, me too.
Yes,
it's correct. Now we have the mass and we have the density. Can you find the volume? Give me an answer only.
That's 6.78 times 10 to the power minus 23.
6.78 times 10 to the power
Minus 23.
minus 23. Who got the same answer?
I get
I
it.
got it, Mr.
Okay,
I
great.
got it.
Very good. Then find A. What's A?
It is R. 4R over
What's A from the volume?
It will be 4.07 times 10 to the power minus 3.
the cubic square.
Okay, give me answer only. I want answer.
Minus 8.
What's the unit?
Centimeter.
Centimeter. Very good. A is actually, as we said, A equal to the cubic root of volume. Okay, now we find A, calculate R. R is equal to what? Now you should say it's actually A square root of 2 divided by 4. What's R?
1.44 times 10 to the
0.50.
No, 1.44 times 10 to the power
Minus
-8.
centimeter. Yes, this is the correct answer actually. Now, if you know this, can you change it to angstrom?
Yes.
Yes. That's 1.44 times 10 to -10.
No, this is meter.
1.4.
1.4.
1.44.
So it will be 1.4 angstrom exactly. Good. I want the answer in angstrom at the end. Is this clear? Any
Yes.
questions?
Doctor.
Good. We can have also, not only what we talked about here is cubes for what? For atoms. Atoms. But we can have also cubes for ionic compounds. Right? Like for example, look at this cube. In this cube, this is an ACl cube. An ACl is face-centered cubic with chlorine minus, and the sodium is taking the rest of the space. If it is face-centered cubic with chlorine, then how many chlorine ions are there?
Six.
Yes, say it loudly. If it's
Six.
face-centered cubic, how many atoms are there?
6.
No, 4.
4.
How many Cl minus? Should be 4. I told you, if it's face-centered cubic, then it is 4. Don't forget, we have 3 cubes. Simple cubic, we have face-centered cubic, and body-centered cubic. How many atoms are in simple cubic?
1.
1. Face-centered cubic?
4.
4.
4.
Body-centered cubic?
2.
2. Keep this in mind. If it is face-centered cubic with Cl minus, then how many Cl minus are there?
4.
4. How many Na plus must be there?
4.
Why 4?
Because it's face-centered cubic.
No, because it's 1 to 1.
For every chlorine.
For every chlorine, there must be a sodium. And that's why in the cube, there are 4 chlorine and 4 sodium. Is this clear? Now, what's the A of sodium chloride? A equal to what now?
2.
2 are what? I wrote this. Explain to me, what did I write?
The diameter of Cl and the diameter of sodium.
Why did I write this? Look at the structure and tell me why is it, what I wrote, is it right or not right?
That's correct.
Yes, correct.
Good. Let's try to the other side. Is the other side is also the same?
Yes.
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 So if I give you, if I want the volume for an ACl, how can you find the volume? Take the radius of Cl and the radius of sodium, find A, and then what's A volume?
A cube.
A cube.
A cube, exactly.
To the power of 3.
Yeah. How about the mass? What's the mass of the cube? The mass of the cube.
From the periodic table.
Yeah, but how many atoms are there? Yes.
4.
4 by molar
4
mass.
times what? What's the mass
Mass
of
of
chlorine?
23.
35.45.
Exactly. Plus what?
That's 4 times
Plus 4 multiplied by 25.
Exactly. And everything is AMU. You change it to volume. Then you can find the density. Is this easy or difficult?
Easy.
Good. Okay. Now, this is another structure. In this structure, we have what's called zinc sulfide. Zinc sulfide. Again, this structure is face-centered cubic in sulfur, S2 minus. Then how many atoms? The sulfur is the yellow thing here. This is sulfur. And the zinc is the small thing in here. They are inside the cube, you cannot see them. If it says face-centered cubic of sulfur S2 minus, then how many atoms or how many ions of sulfur are there?
4.
4 S minus ions. Very good. Then how many zinc must be there?
The same.
0. 4.
4 again. Look at them. 1. They are inside the cube. 1, 2, 3, and 4. It must be 4. Why are you saying it must be 4?
Because it's
Yes,
1 to 1.
For each S2 minus.
1 to 1 again.
For each
Okay.
S2 minus.
Again. What?
The zinc is 4 because it's for each S2 minus.
Well, it's zinc. Zinc 1 to 1. Zinc to sulfur. If there is 4, there must be 4. 1 to 1.
Yeah, that's what I mean.
Yeah. Good. Let's solve this problem quickly. The edge length of NaCl atom is 564 pm. Determine the density. Quickly. What is given to you here? What's this 564?
A.
What's a unit?
Picometer.
P. Picometer.
How can you change it to centimeter? I want it in centimeter.
10 to the power
Minus
of
12.
minus
564 times 10 to the power minus 12, what?
minus 10.
Meter. And then 564 times 10 to the power minus
10
10.
centimeter.
to make it centimeter. So this is the mass in centimeter, I mean the edge in centimeter, find the volume. Okay, keep it in you with you. Now I want the mass. What's the mass of the cube?
We take it from the periodic table.
Yes. Actually, 4.
Number of atoms.
What?
Doctor, how did you know it's 4?
He said that, we just said it a while ago. This is sodium chloride.
Oh, okay, it's the same question.
Of course, sodium chloride. I'm telling you, sodium chloride.
It's always face-centered, doctor.
How do we know about other compounds?
Oh, now I will tell you. Like, for example, this one, I told you, it's a face-centered cubic with S. All right? And then I told you to find the zinc. Clear?
Okay, so it will be given in the question.
Yes. Find the mass. How can you find the mass? It's 4 times the mass of chlorine plus sodium. All of this is AMU.
3.838
Divide by the
multiplied by
Avogadro.
10 to the power of minus 22.
Give it to me one more time, please.
3.88 multiplied by 10 to the power of minus 22.
Fantastic. So, and you have the volume, you calculated the volume, which is a cube. Go ahead and find the density.
2.17 multiplied by 10 to the power of minus 30.
No, wrong.
2.17.
Only 2.16 according to my calculation. Gram per centimeter.
2.16.
Okay, good. Done with this. Now, we're going to talk about covalent crystals. Covalent crystals. We have what's called network covalent. Network covalent. You have to memorize this word. Network covalent. And I want you to know these only 3 compounds of this type, which is diamond, and then graphite, and then the third one is sand. What's the diamond? The diamond is carbon atom. Look, this is diamond. This is the diamond. You know the diamond? The expensive material.
Yeah.
Diamond consists only of carbon and carbon and carbon, and each carbon is bonded to 4 carbons, and then this carbon bonded to 4 carbons, and this carbon bonded to 4 carbons, and this carbon goes to 4 carbons, and this carbon goes to 4 carbons, everywhere. And these are very strong bond. In fact, this is the strongest compound that we know, and the melting point of diamond is 3,000. More than 3,000. Clear? Why? Because there is a strong covalent bond everywhere. This is the probably strongest bond that we are familiar with.
Even more ionic compound, doctor?
No, it's not ionic, it's only carbon.
I mean stronger than ionic compound.
Stronger than ionic compound, yes. كلير؟ طبعا تعرفون في ايش استخدم الدايموند غير الجولري، طبعا الحريم يحبونه لانه غالي، ولكن في ايش يستخدم الدايموند؟
حفر الأنفاق.
للحفر البترول، يعني احنا في السعوديه نستخدم بكثره في حفر ابار البترول. Why is that?
Because it's very strong.
ما يذوب مهما يذوب الصخور، هو ما ذاب. درجة حرارته 3000 أكثر من 3000 عشان يذوب، عشان يتحول لليكويد. Clear? The second thing is the graphite. البنسل اللي نستخدمه في الكتابة. This is graphite. It's also carbon, but the carbon are put in layers. Can you see? This is also carbon atom. It's bonded to carbon, 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 and each carbon is bonded to 6 carbons, but it's in layer. See, you can see first layer, second layer, third layer. So when we write like this, what we are doing, we are separating the layers, but also in between them, the melting point of this compound is very high. The third layer, the third compound that is very high in temperature is sand. تعرفون شو الساند؟ Silicon oxide. Silicon oxide is a ramen. Yes. And what's silicon oxide? It's silicon with oxygen. Again, the silicon is bonded to 4 oxygen, and each oxygen is bonded to 2 silicons. And this is continuing, and these are known as network You have to memorize network covalent compound. Only I want you to know 3 examples. What are these 3 examples? Quickly.
Diamond.
diamond, graphite, and silicon oxide.
Sand.
Sand. طبعا ال SiO2 could be sand or glass also. الزجاج. Because الزجاج يصنع من
Last one
electrons.
heated, right?
Yeah, glass is heated sand. Okay, and these are very high in melting. درجة الغليان حقهم عالية جدا. Is this clear?
Yes.
Yes.
Now, molecular compounds are like water, like ice, H2O, ice. What's the force between them? It's very, very weak. At what temperature you can dissolve H2O?
0 Celsius.
0 degree. شو الفرق بينه وبين الجرافايت؟ بين الدايموند؟
More than 1,000.
What's the property of molecular crystals? The compound made of molecular crystals. اللي the forces between them is hydrogen bond or what is it? London dispersion or what?
Dipole.
Dipole. You must memorize these 3. And are these strong bonds?
No.
Extremely weak.
What about hydrogen bond, mister?
Yeah, it is. I mean, compared to diamond, is extremely weak. That's why the hydrogen bond is available in water. What's the temperature of melting the water?
0.
Because you can break the hydrogen bond at 0. That's the meaning. But at what temperature you can break the carbon-carbon bond in diamond?
More than 3,000.
More than 3,000.
Is this clear?
Yes.
Okay. You have to memorize these 3 bonds, but these 3 bonds are all what? Considered to be
Covalent.
Very weak.
weak bonds. And these are available in what type of crystals?
Molecular.
Molecular crystals. Last thing, this is the metal crystals. Crystals. If you have metal, usually the metal is arranged like this and the electrons are around it. And this is the bond. This is called, the electrons are making what's called electron C or electron cloud. ليش سموها الكترون سي؟ الالكترون مسوي زي البحر والاتمز فاقده الكترون مسوي البحر والatoms are around like this to make the shape crystals like this. And the temperature usually for metallic compound is around 800, between 500 to 800 degree to melt it. So which one is stronger? Molecular compounds or we have third compounds also, ionic. Ionic take place between what and what?
Metal and non-metal.
And the metal with non-metal, usually the melting point is around 800 to 1000. So we have 4 compounds, molecular compounds, network covalent, we have metallic compounds, which is consisting of metal only, metallic compound, and the last one is for ionic compound. Which one has the strongest bond?
Network covalent.
Network covalent. Okay, which one is the second?
Ionic.
Ionic.
Ionic, exactly. What's the third one?
Metallic.
Metallic.
Metallic. And the fourth one?
Molecule compound.
Molecular.
Molecular is, I put many because it's the weakest. Molecular is very weak. Clear? This is very important. You have to know this. And here's the table, give you example of all the crystals. Ionic. This is ionic. Ionic between what and what?
Metal and non-metal.
Exactly. Covalent between what and what? We have four compounds that we memorize. Network covalent. What are these network covalent? I want you to know only 3 examples. What are the examples?
Diamond,
and
sand, and
Graphite.
graphite.
Quartz. And this one? C, what?
Graphite.
Fine. All right. Good. Next, metallic. Give me example of metallic.
Iron.
Iron, sulfur, not sulfur, sorry, copper, iron, Mg, sodium, and this is also can make. What type of bond we have here?
Metallic bond.
Metallic.
Metallic bond. What do you mean? How is the metallic bond made? By the electron? Cloud or electron?
C.
This is the other name for it, electron C, exactly, or cloud. Is this clear? I hope. And the last one is molecular compounds. It's between non-metal with non-metal, and it's between argon atom by itself, CO2, but between water, molecular compounds like sugar, and these are the weakest bond. Good. Okay. The mass, okay, the metal iridium crystallized with a face-centered cubic cell. Determine the density. Can you find the density? Because the unit cell is 383 ppm. We solve one like this one. What's this 383?
A.
A. It's a face-centered cubic. This means how many atoms we have per cube?
4.
4. What's the mass of iridium?
$192.22.
Yes.
AMU. Change this to gram.
1.27 times 10 to the power minus 21.
Minus what? 20?
21.
1.28.
Yeah, okay, 28 is fine. I didn't know. Okay. Did you multiply by 4, of course?
Yes.
Yes, yes.
Now we have this one's 383 times 10 to the power minus 8 centimeter. This is A. So what's the volume?
Isn't it 10, Doctor?
10, Doctor.
Oh, yes. See, I make mistakes, of course. Yes. Sorry. 10 minus 10. Because I thought it's angstrom. It's picometer, not angstrom. So what's the volume?
AQ.
Yeah, give me a number.
Uh,
5.6 times 10 - 23.
Okay, good. Be the density.
22.7.
Exactly. Very good. I hope this is correct. And yes, it is 22.7. Last thing I'll talk about today, amorphous solid and crystalline. What's the difference between amorphous and crystalline solid? It's this one. This is crystalline solid, and this is amorphous. What's the difference?
The shape, structure.
Crystalline arrangement.
The
has no
geometric
unit.
structure.
Yes.
It
This
has no
one
unity.
well arranged, and this one
None.
Not arranged.
okay. And with this, we'll stop here. Remind me tomorrow we'll finish chapter. We are at 11.6. I will start from 11.6 tomorrow. And now, as usual, let me close this. Okay, and then go to this one, and then okay, the attendance is open. Go ahead and take attendance, and you can leave right away.
دكتور شابتر 10 دخل معنا بالفاينل ولا لا؟
طبعا. جاتكم الاعلان؟ ما جاكم الاعلان؟
جانا، بس انا اتذكر ان احد سالك عن الموضوع ذا وما ادري، يمكن ملخبط. توقعتك انك قايل انه مو معنا. يمكن ملخبط.
شابتر 6 الى الاخر. 6 و7 و8 و9 و10 و11 و13. 7 شباتر.
تمام، الله يرحمك. شكرا.
دكتور.
نعم.
هذا آخر كويز خلاص صح؟
الجاي آخر كويز. لا في واحد الأسبوع الجاي.
شابتر 11.
شابتر 11 أعطيتكم أوريدي، أعطيتكم سؤالين. قلت لكم سؤال عن كاسس كاليبرن وسؤال عن الدنسيتي أوف دنسيتي أو إيدج أو شيء كيوبيك كلوز باكينج.
كيوب كان.
الكيوبز نعم.
يوم الأربعاء يا دكتور.
يوم الأربعاء نعم إن شاء الله.
الدكتور ممكن إذا ما عليك أمر ترسل بالواتساب؟
طبعا برسل لكم معلومة بالواتساب.
الله يهينك.
دكتور
لحظة شوي.